Hi, my name is Tim Bennington-Davis. I'm an associate fellow at Verizon. I'm an engineer. So this talk will be all about engineering. My specialty these days is communications engineering, specifically Wi-Fi test engineering. But I'm an electrical engineer by trade, so that'll be pretty much what I talk about here. What my company does, I work for Verizon, and there are kind of two pieces of Verizon. One is the cell phone company, and you know them through cell phones and Verizon Wireless. Verizon also has another part of their company, and that's the part that I work for, where we deliver internet to homes. The brand name is Fios. It's a fiber optic network that runs to the house. And specifically what my group does is tests the Wi-Fi routers that would be in your home. So if you have Fios, if you happen to be on the East Coast, that's where a lot of the Fios business is. And you get Fios service, you'll get a Wi-Fi router in your home from Verizon. And the job that my group does is tests that router, all of the features and functions. Specifically, what I specialize in is Wi-Fi. So how well does the Wi-Fi functionality of that router work? That's what my job is. So my roles and responsibilities are primarily to write tests and then test the products that vendors will bring in before we put those routers into a network. We have to make sure that they're stable and they work well and they've got good coverage. And so all of those things are what we test. We have a lot of different test equipment that we use. We use a lot of client devices like laptops and phones and things of that nature that have Wi-Fi in them. We also have RF chambers. These are chambers where no radio energy gets in or out. So we'll go in and we can do very specific tests. We have things like turntables where we can turn things around, and we're always looking for how well does a router work no matter what angle you put it at. So the roles and responsibility are to come up with test methodologies to test the product before it goes out to the customer, and then do those tests, and if there are problems, work with the designers to solve those problems before the products go out to customers. The education that I have is a bachelor's degree in electrical engineering. I went to the University of Cincinnati, and then got a master's degree in engineering management at the University of Portland. But in the educational endeavors for communications engineering, software engineering, electrical engineering, computer science, computer engineering, and then there's communication technology engineering. Those are all different threads that would work into a job that like I have. Part of the folks in our group work on security, so just making sure that the communication networks are secure and encryption, and there's a whole area of study around encryption technology. There's the communication technology both at the physical layer, so the RF piece of things, the radio frequency, or the Ethernet cabling pieces of it. There's electrical engineering there. These devices are all software based, so there's quite a bit of software engineering, both embedded, that's more tied to microprocessors, and applications engineering, and then network engineering. So there are several folks that I work with that have degrees in network engineering, so they understand TCP/IP protocol and how information flows over the internet. Those are all branches that bring you into communications engineering. How we're using technology in response to the epidemic, well, we're a communications company, so we provide both wireless and wired communications mechanisms, and we're using it every day. The laboratory that I work in is in Ashburn, Virginia, but I live in Oregon. So I'm here in Oregon and staying in place, but using the network between here and Virginia to run all of the test equipment that I have access to in Virginia and harvest the results, and I'll write reports from here and then mail them back. And of course there are Zoom and WebEx and Skype sessions. We use WhatsApp between ourselves as workers. So if we need to have a quick conversation like we would normally have in a hallway, we'll get WhatsApp up. Or put a Skype session together and talk over whatever the topic of the day is. So we're using technology and we're providing that same networking technology at the same time. Advice. Well, as an engineer, if you are interested in an engineering career, what I would urge you to do while you are in high school is build things, experiment with things, work on projects. If you're if you're interested in software engineering, take some C programming courses or Java programming courses that are online and try writing some code. Go take a class if you can find one. If you're interested in circuitry and electronics, there are kits that you can get a hold of. A great place to start is to get an Arduino. They're not very expensive and you can get them from Amazon. And it gives you some examples of how to use electronics and software together to come up with a bit of a hobby yourself, to make lights light or turn on fans or whatever project you'd like to do. And there are a lot of projects out there, and the Arduino community has posted many, many different examples that you can learn from and use. If there are maker communities that you can go meet, go do that. Go find out. There's a great place for mentors in the maker community. Somebody who knows how to work with wood or how to work with metal or work with electronics will be willing to teach you. I'm a mentor for First Robotics. If you have a First Robotics organization nearby, I think it's an excellent place to get engaged, because what those teams do is work together to build a robot and then go compete with it. And many of those things I think are good advice for you, because learning a skill, learning how to work with metal or electronics or software in order to get the robot built and working is great. But also learning to work with other people, taking an undefined task. We need to build a robot that lifts shoots a frisbee or shoots a ball or lifts something up. Okay, working through, what are the mechanisms going to look like? How would we actuate them? How would we control them? And prototyping and getting it wrong and innovating, how can we make it better? And working together with other people, I think is a very important thing for you to do, because it sets the stage for how you're going to work together in college on projects and ultimately how you'd work in a career. Learning how to tackle technical problems using scientific method, using prototyping, using each other's skills, learning how to try something and see that it fails, but observing what came out of that failure, what worked, what didn't work, how do we now make the next version of it better, I think is all important engineering pieces. So go build things. If you're interested in automotive engineering and you've never taken an engine apart, go to the junkyard and get an old lawnmower and take it apart, take the engine apart and see how everything works. Electronics, find electronics things and take them apart, unplug them from the wall, but find out what's inside of them, how they work. Salary, the salaries, my data is a little bit old, but you can find some of this on the internet. But engineering salaries are well-paid positions. Starting salaries will be over $75,000, maybe even in the 80s and 90s these days. At a master's level, you could expect to make over $100,000 to start, and there are many opportunities to advance your salaries. Robotics is a big area, space travel is a big area, alternative energies is a big area, chemical engineering, the chemical engineers make a load of money, so if you're good at chemistry, go for it. What I would say is if you think if I'm going to be an engineer, I've got to be great at math and great in physics. Not necessarily. There are plenty of jobs that require you to be fantastic at math and physics and sciences in order to be effective at your job in engineering, but not all of them. So if you struggle with math, don't worry about it. If you're interested in engineering and how things work, stick with it. And if you're interested in software, you may not have to be the person that's writing algorithms and things like that. The most exciting part of my job is the number of things that I get to learn every day. I've been an engineer for 40 years, worked with several different companies, and have gotten to learn so much about so many different technologies, and I love that. I love just being able to see, sometimes invent new technologies, but sometimes observe what other people have already come up with, and that's the most fun part of the job, is just learning something new every day. Hopefully this helps you, and good luck.